Okay, so I just wanted to very quickly run through the volume and area notes in case you weren't in class or in case you needed a refresher. So this is what they look like. Question number 1 is going to be a calculator question, and question number 2 is going to be a non-calculator question. Okay, so the first thing, if you're looking at question number 1, if they give you a graph or if they just give you the two functions, you need to be able to set up, okay, what are your intervals? Because you're going to get points for these. They're called limits of integration, but you're definitely going to get points for these. So you need to be able to find A and B, and they won't necessarily give you those or even tell you to go find them like I wrote over here, but you need to know how to do those. So use your calculator, go ahead and graph these two equations, change your viewing window so that it matches the picture shown, so that you're looking at on your calculator what you're looking at on the piece of paper. So the value for A, the x would be 1.9622 and 3.9243, that's the x and the y, and B would be 3 for the x and 3.1411. So on your calculator, A would be an intersection, and then B would be looking for a y value given an x value, because you know that x equals 3 here, and you're looking for a y value here. Okay, so you need to have those two values down. You determine which one you need to use and whether you need to use the x or the y depending on what they're asking you to do. Okay, so first one says find the area of region A. Anytime they ask us to do area, we're going to give a positive. We're going to do top minus bottom. So generally, unless they tell us differently, we're going to do our areas in the dx. So we're going to make our rectangles perpendicular to the x-axis here. So area of region A, the top would be f of x. The bottom would be g of x. And we do dx, which is our width, and then our interval would go from 0 to 1.9622. Remember that it's important to include at least 4 decimal places through here, so that your answer will be correct to 3. So go ahead and put that in your calculator, and you get 3.418. Okay. Area of region B you could do in two different ways. One, you could try to find the area of all of this, and then subtract out your answer for part A, so that you would just be left with part B. Okay, but we're going to do it a little differently. We're going to do it in two pieces just because it'll help out later. So if you were doing area of region B like we just did, the problem with area B is that the top changes. The bottom is the same function every time. If we put our rectangles in here, okay, the top at the first part is going to be g of x, but the top in the second part of area B is going to be f of x. The bottom is still a 0 the entire way. Okay, so we're going to go ahead and put it together in two different integrals. So the first integral, the top is going to be g of x, and the bottom is going to be 0. I'm going to do dx, and our interval is 0 to 1.9622. No, you don't have to show the 0. Okay, and then the second integral, the top is going to be f of x, and the bottom is going to be 0. We're going to do dx, and our interval is 1.9622 to 3. Don't have to show the zeros, but we go put this in our calculator and you get 572. Okay, so areas you need to be able to get pretty quickly. Just doing top minus bottom. Okay, so then the volumes part is a little bit more difficult. So we're going to do cross sections and revolving, but when you see C, it says find the volume of the solid form by revolving. I just kind of want you to go through these steps every time. When you see revolving, you need to think circle, and you need to ask yourself, okay, do I have 1 or 2? When it says area, you need to go figure it out. If it says revolving the curve, you know it's 1, but if it says area, you got to go figure it out. So they're going to tell you what to revolve it around, and that's really important. You have to pay attention to that. So this says take area A, which is here, and we're going to go around the x-axis. So what we do is we start on the x-axis because that's going to be our middle, and we're going to draw out through area A and figure out whether we have 1 or 2 curves. So you have 2 lines that hit the radii and that belong to area A. So our general format is going to go big R squared minus little r squared. We have to ask ourselves dx or dy. Since we're on the x-axis, we're dx. And that tells us that our interval is going to be in the x variable. Well, for A, the x's go from 0 to 1.9622. Okay, I'm also missing a piece. Whenever you're doing circles, you better have a pi out front. If you miss that pi, you're going to miss 1, maybe 2 points, because you'll miss a point for having that out there, and then you'll miss the answer point. Okay, and then your job is to figure out what your big radius is and what your little radius is. And remember, they're always, always, always top minus bottom when you're going vertical. So for the big radius, the top is up here and the bottom is down here. The center of the circle will always be part of the radii. So the top here would be f of x, and the bottom would be 0. And then the same thing for the short radius. Short radius is from the center to the first curve you hit. So top minus bottom, that top is g of x, and the bottom is 0. And that's all the work you have to show, because everyone knows what f of x and g of x are. You get to put this in your calculator, and this one comes out as 53.510. That's what the pi multiplied in. Okay, so next part C says find the volume of the solid form whose base is area B and whose cross sections are right isosceles triangles. So when they tell you a cross section, they're going to give you a shape. And instead of doing the circles right away, which we knew was pi r squared, we're going to put down generally the area of the shape they're telling us. So it's a triangle, it's 1/2 base times height. Now I should have written here perpendicular to the x-axis, and the AP test will be a little more careful about that. Tell you that we're putting these triangles perpendicular to the x-axis, which tells us the interval variable that we're going to use. But what we're doing, just going to quickly draw one three-dimensionally. We did back when we first learned these. This is what we're putting in there with this is the base. This is sitting on your paper, and then this is coming out at you. This distance is out at you. Okay, so that is the height right there. Okay, so some things to modify this, okay, is you knowing that they're isosceles tells you that the base and the height, whatever this base is, the height has got to be the same thing, because that's how you make isosceles. So we can take this 1/2 b times h and turn it in 1/2 b times b, because they're going to be the same thing, or we could just simply write 1/2 b squared, and then we'd have our dx. Okay, so the problem with this though is when we look at our base, if we drew our triangle over to the left side of area B, we would have a different base than if we drew it over the right side, because once again we're doing top minus bottom. Even though the bottom is the same in both of these, the top is different. The top on the left side is g of x and the top on the right side is f of x. So we're going to have to split it just like we did in part B. Okay, so we're going to go ahead and do this general formula, but we're going to do it in two different integrals because our top changes. So we're going to have 1/2, and then our base for the first one is going to be top minus bottom, so g of x minus 0. We're going to square that. We're going to do dx, and our x interval for that part would be 0 to 1.9622. Okay, and then we're going to add on the second part, where we're going to go 1/2 base. So our top is f of x, and our bottom is 0. So we get 1/2 f of x minus 0 squared. We're going to do dx again, and our x interval is 1.9622 to 3. We don't have pi in here because they're triangles and not circles. You'll only have pi with circles or semicircles. So if you go ahead and put this in your calculator, you get an answer of 11.738. And you, again, don't have to have these zeros in here, but it's important for you to know that you're always doing a top minus bottom there whenever you're looking at a length. Okay, and then part E asks you to find the volume of the solid form by revolving. So when we see revolving again, it's circles. We just have to determine one or two, so it says revolve area A. Okay, so we've got to go a draw. We've got to figure it out around the line y equals 5. So they tell us what to go around. However, y equals 5 is not pictured. So if we draw y equals 5 in, it's going to be a horizontal line up here. And now our job is to start at that line and go through area A. So once again, area A is this weird looking shape. We start at whatever they told us to go around, the axis of revolution. We draw through our area A. We hit two lines. So general form, we're going to go pi big R squared minus little r squared. Y equals 5 is a horizontal line just like the x-axis, so it's going to be dx, which just tells us our interval is going to be x's 1.0 to 1.9622. Then we just have to figure out again what our big radius is and our little radius. So again, follow these steps every time and they'll keep you from getting confused. Our big radius is going to be from the axis to the second curve that you would hit. So here to here, and you're going to do top minus bottom. And the top here is 5, and the bottom is g of x. And that's it for that radius. Okay, and so then the short radius is from the axis, where they're telling you to go around, to the first curve you hit. So the top there is 5, and the bottom is f of x. And that's all the work again that you have to do. It's no more difficult than part C was. And now we just have to type this into our calculator, and you get 53.865. That's question 1. So this was meant to be a calculator question. Functions are a little bit harder. We have decimal numbers. Okay, but they can also throw you non-calculator questions. Okay, so it's a little bit simpler function on question 2. We just have h of x, which is x cubed, but we also have this line up here that's kind of dashed in, but this is the line y equals 8. So there really are two functions here. You could call it g of x, you could call it something different, but that's y equals 8. Okay, and then they have this line x equals 2 here, which depending on what axis we're going around, it can be part of our interval or it can be part of the actual equations we're using. So we're going to try to work this without a calculator. So you're going to see me working integrals by hand this time. Okay, but usually if they give you a non-calculator question, they're going to make the whole question non-calculator, but they'll only make you integrate 1, maybe 2, but they'll usually say set up but do not evaluate the next integrals because they've already tested your integration. They just want to see your setup. So area of region C, we're going to do top minus bottom like we've been doing this entire time. If we were to put a little rectangle in here in area C, and the top is 8, and the bottom is h of x. Well, since I'm doing this by hand, I probably don't want to put h of x. I've got to put x cubed in there because I need to actually integrate this. Okay, and so then our thickness of our rectangles is delta x or dx, and then my x interval for area C, x's start at 0, and they end over at 2. So there's my integral. So the only difference between this and the last one is this: if this doesn't have a calculator, you get to do this integral by hand, and the thing that most people forget to do is actually take the antiderivative first. You don't go plug in those numbers in first, you take the antiderivative. So we take the antiderivative, we get 8x minus 1/4 x to the 4th, with bar 0 to 2, and then we can plug in top minus bottom. Okay, and so we plug in a 2, I know that's going to drive some of you guys crazy because you are more than capable of multiplying 8 by 2 and taking 2 to the 4th power. Okay, but if we plug in 0, you get 0. My point with this is, if it's free response and they take a calculator away from you, this is a fine answer. This is no more wrong or right than the answer that you simplify down to 12. Those are equivalent answers. If you can't get the 12, that's okay as long as you have this answer, and that's fine. Okay, and then we'll do area D. So again, we're going to put our little rectangles in area D this time. We're going to do top minus bottom again. So we're going to integrate. I'm going to go top, which is x cubed, bottom, which is 0. We're going to do dx, that's our little rectangles, and then we're going to go from 0 to 2 again. Okay, so we've got to again integrate this, so we get 1/4 x to the 4th, and then 0 doesn't integrate to anything. So then we have 0 to 2, and we're going to do top minus bottom, and we're going to put in 1/4 2 to the 4th, and put in 0. And that's as far as you need to go. If you want to get 4 as an answer, yay for you. Okay. Alright, so for the rest of these notes, we're going to pretend that each one of them, C through E, says set up but do not evaluate. So we're just going to try to set up the integrals. We're not going to actually take the antiderivative and plug in anything. Okay, so C says find the volume of the solid form by revolving area D around the line y equals -2. So revolving, we're thinking circle. Area, so we have to figure out 1 or 2, and we have to know what we're going around. So the line y equals -2, which is not pictured. So we're going to draw it in. Alright, and then I'm going to outline area D. This is area D. Okay, so if you draw from the axis of revolution, what they tell you to go around, up through the area, you will hit 2 curves. Which tells us right away, we're going to do pi, big R squared, minus little r squared. Y equals -2 is parallel to the x-axis, so we're going to do dx, which tells us that our interval is in x's, so 0 to 2. And our job is to figure out what our big radius is and our little radius. So the big radius is going to be from the axis to the second curve you hit, the far curve. So there the top is h of x, and the bottom is -2. Okay, and we're going to do top minus bottom, so we have h of x minus -2. Yes, that comes out as h of x plus 2. Okay, but if you will do the same thing every time, it'll work every time. Okay, and you can call it h of x this time because we're not actually going to evaluate this whole thing. Okay, if you were evaluating, you'd probably want to plug in x cubed. Okay, and then little radius is going to be from the axis of revolution, what they tell you to go around, out to that first curve that you hit. So there the top is 0 and the bottom is -2. So that comes out as a 2 overall, but you don't have to have that separately. That is good enough work. That is a completed question on the AP scale. Okay, all right, so D though, D and E are a little tougher. Okay, D says, can you find the volume of the solid form by revolving area D around the y-axis? So the y-axis pictured here. And we're still doing area D. So when we see revolving, we're doing circles. Area, we have to figure out 1 or 2. Y-axis is pictured. We're going to start on the y-axis and draw through area D. Okay, so this is a horizontal line this time, but still, you hit two lines that belong to area D. So we're going to go pi, big R squared, minus little r squared. But this time, we're going around the y-axis, a vertical line, so we're going to do dy. Which means for our interval, we're using y's, and D starts at 0 on the y's, and it ends up at 8 on the y's. So our interval is 0 to 8. Okay, and usually that's worth a point. Okay, and then our job is to figure out what big radius is and little radius. So since we're going horizontally, we clearly cannot do top minus bottom here. We're going to have to do right minus left. We always want a positive, but we're going to have to do right minus left. So big radius is from the axis of revolution, whatever they're telling you to go around, and then out to the second curve you hit. Okay, so we're going to do the right minus the left. So the right is x equals 2, and the left is 0. Okay, so that just comes out as 2. All right, on this one though, the short radius one, that one's the one that's a little harder for people. Okay, so the short radius goes from the axis of revolution out to the first curve you hit. Okay, and so you're going this direction. We can't be working in y's. We're not doing y's, we're doing x's. So the right is x, it's an unknown, and the left is 0. Okay. However, this x changes depending on this function. So this function is really y equals x cubed, or x equals the cube root of y. So when you actually go plug this in, you're going to need to have the cube root of y minus 0. You don't have to show the 0, because we're dealing with dy's. Okay? But when you're going horizontally like that, you have to do right minus left. Okay, all right, and then last one. That's it for that problem. If you're not evaluating, that's all you had to do. Okay. The last one has something that is again not pictured on it. It says find the volume of the solid form by revolving. So circles. Area C, so we needed to figure out 1 or 2 curves around the line x equals -3. X equals -3 is not pictured, so we need to draw it in. X equals -3 is right here. Area C, if you outlined area C, okay, that's what you would have. Okay, so x equals -3 is in there. We're going to go from that through our area, and we hit 2 curves. And so we're going to have pi big R squared minus little r squared. X equals -3 is parallel to the y-axis, so we're going to go dy, which means we're going to use a y interval. And area C's y interval starts here and ends here, so it starts at 0 and ends at 8. And then our job is to figure out our big radius and our little radius. So big radius is from the axis to the second line you would have hit. So we're going to do right minus left again. So this is again x, and then this guy is -3. So right minus left is x minus -3. So we're going to have a problem with that x here because that's a dy. And so we're going to call x, just like we did before, x is equal to the cube root of y. So this is going to be the cube root of y, and then plus 3 if we take our minus minus. Okay, and then our small radius should be from the axis to this first curve you hit. So the right would be 0, and the left would be -3. So we end up getting 3 there. And that's all that we would have to do. So that's area volume. There's lots for you to practice. Most are calculator questions on your homework.